Magandang araw. Ako si Kui Code. Welcome back to my channel where I teach Python through fun and practical examples. Today we'll be diving into more software design patterns. So this is the state pattern. The state pattern is a behavioral design pattern that lets an object alter its behavior when its internal state changes, making it appear as if the object itself has changed to a different class. This pattern suggests that you create new classes for all the possible states of an object and extract all state-specific behaviors into those classes. One thing to keep in mind, though, is that if you want to add or remove states later, you also need to update every other state that interacts with it. So it's best to plan out your state transitions carefully and try to include all the states you're going to need beforehand before you use this pattern. This is also an extension of a pattern called the strategy pattern, which deals with multiple ways to implement a state rather than which states exist, but that's a video for next week. So in this example here, we have an enemy class and we have two different states. We have patrolling and attacking, and the player's distance from the enemy is what determines when the state changes. So if you're more than 6 units away, it'll go to patrolling, and if you're less than 6 units away, it'll go to attacking. And then this is our output. So the distances is just a mock-up simulation of a player's movement or the distance between the player and an enemy. So, for example, the player is 10 units away, and then they're 8, then they're 6, and they're 4. So this is simulate the player getting closer to an enemy, and then, of course, getting farther away afterwards. So when we're 10 meters away, we're patrolling. 8 meters away, guard is still patrolling. 6, still patrolling. And then once we get to 4, it goes from patrolling to attacking. And then as we're walking away, it's still attacking. And then once we get too far away from the goblin, then it switches back to controlling. So this, works, but there is a better way to do it. So one thing I'm going to do here is I'm going to simply import abstract method, because we're going to make an abstract class, which is basically the base class of all the different states we're going to have. So there's the base class for all the states. We're going to pass the player distance into that. And now let me just make some changes to this. So we have update. We're not going to have all of the different states hard-coded in here. Instead, we're going to just have self.state.handle, which is going to be from this. And then we can just pass in self and player distance. And then what we're also going to do is have a way to change the state. So set state, self, you pass in the state, and then self.state equals state. And then rather than having this as a hard-coded string, we're just going to have a default state, which is patrolling, that I'll be making in a minute. So this is the default state. And then I could also put a print statement here for the state here. So whenever we switch states, it'll show that. So now I'm going to make the implementations of this. So we're going to have a patrolling state, and then we're also going to have a attacking state. So we'll just simply do this. So there's our patrolling state. So basically, we have a patrolling state. We have the player distance. It's going to give us some text. And if the player distance is less than 6, rather than just having an output like we had before, we're simply just calling the enemy class's state or set state method and set the state of the enemy class. Now that this state is going to be changed to the attacking state, when we call update, it's not going to, it's going to call the handle method for the attacking state, which is going to be in our other one, which I'll grab that now, which looks like that. So basically, when we are patrolling, if we are getting closer, then the enemy class's state is going to switch to attacking, which means next time it's going to go inside of here and it's going to start printing out the enemy's attacking. And then, of course, if we get farther away from it, it's going to switch back to patrolling, and then it's just going to, do that, forever back and forth. So let me go ahead and run this and see our results. I think this is still good. Unless I missed something. Let me just close this and hit F5. So look at that. It still works. So now we have patrolling, patrolling. Now we're close. Switch into attacking mode. Attacking, 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 attacking. Switch to controlling mode, and then back to controlling. So that works perfectly. But as I mentioned, if we were to add a new state like idle where it's neither patrolling or neither attacking, this is still good because the enemy class doesn't know anything about which type. It doesn't really matter which type it is because you can still set it to um, the idle state externally. But the problem is that we need to we'll have our idle state here, but then we need to have some extra logic in here to decide when we're going to switch to the idle state. That's why when you're using this pattern, it's better to plan out ahead of time what state you're using, and if you have a situation where you need to add a bunch of new states on the fly, maybe you'll just consider you know if there's a better way to do that, or like why would you need to add in a whole bunch of states on the fly to begin with. It's better to just to have everything in your code already for the different states, and then maybe have some not available until like later in the game or whatever. So that's it for this video. Just a quick video. If you found this video helpful, please like and subscribe for more coding challenges or more coding examples. Let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.